Hello guys, in this video I'm going to be walking you through how to answer every single question in paper 1, the arithmetic paper from the 2022 SATs. Please do like and subscribe and follow me if you'd like to view content from the other papers. I also have walkthroughs for paper 2 and 3, the reasoning papers, as well as other years of SATs. So don't forget, like and subscribe and follow. This is a straightforward addition problem. The main thing you need to think about in this is to line up your digits correctly. So I like to always put the larger number first. The larger number is in fact the first number in the number sentence. If it wasn't, I would switch it round. The 501 and 649, you can switch them around if you want to, but it's not necessary. They're both 3 digits, so you simply write them in. The main thing is that you write them in the right place, okay? What we sometimes see is this and then this. You can see the digits are not lined up correctly. Also, try and keep your digits to the squares. It just helps you to have everything lined up correctly. Okay, and then you're simply going to add. So your 5, your 1 and your 9. Now, when I add, I like to try and look for numbers that can group together easily. So if I was adding this, I would be looking at adding these two first. So in my head, I'd be doing, okay, the 9 and the 1 is 10 plus the 5 is 15. Now, obviously, you don't have to do it like that. You can do 5 plus 1 is 6, 6 plus 9 is 15. But I always find that I like to group together numbers that are, use my number bond. So the 9 and the 1 makes 10. It makes it a lot easier to find that that is 15. Remember to put your 5 in the ones column and carry the 1, which is 110, over to your tens column. We've now got 5 plus 4, which is 9, and remembering to add the digit that we've put down here. So that is 10. And then again, here you might want to add 1 plus 5 plus 6, or you might want to group together. So it's just as easy to do 1 plus 5 is 6, plus 6 is 12, plus this one is 13, remembering to carry the digit. 6 plus this one here is 7. Okay, just always double check if you added that your answer is bigger than the biggest number in your problem. It is. And remember to write it in the answer box. In this question, it's a bit of a trick, really. It's not a trick, but what a lot of you will do is start to write it out like this. Okay, there is no need. For this question, what we're looking for is that you are showing you understand anything multiplied by 0 is 0. So you don't even have to do anything. You don't have to write anything out at all. Anything multiplied by 0 is 0. Just pop the 0 in. What that does is it saves you a lot of time. The arithmetic paper has a lot of questions in a small amount of time. So where you can save time, save it. There's no need to write anything out for this question. It's multiplied by 0. The answer is a 0. For this question, we have a missing number problem. We are looking for 10 plus something makes 302. For this, you can use your understanding of inverse. So the inverse of adding. Inverse of adding is subtracting. So we can go forward. So if we know that 10 plus something is 302, we know that 302 take away something is 10, but we also know that 302 take away 10 will equal that missing value. Okay, so it's understanding that when you add, these two values can swap around. When you subtract, these two values can swap around. So the easiest way to find this is to think about what we're going to add to 10 to make 302 is by subtracting it. You might also use a bar model. Bar models are very useful in calculation. So if I put 10, and I don't know what that is, but I know that this adds up to 302. That might help me to visualize that I need to do some subtracting. I need to do 302 subtract 10. Now 302 subtract 10, you could do this if you're not able to do it mentally, but hopefully you are able to mentally count back in tens. If you're not, 2 take away 0 is 2. We can't do 0 take away 1. 10 take away 1 is 9, and 2 take away 0 is 2. It's 292. If you need to, you can do a check calculation. You can do 292 add 10 just to check that the answer is 302. For this question, again, if you're thinking about speed, you may be able to just do this in your head. What I would hope you might see is that 24 divided by 2 is 12. This would be what you would do in your head. So 2,400 is 100 times bigger than 24. So your answer is going to be 100 times bigger than 12. If you're not able to confidently do that in your head, do it in a bus stop, because that is equally as fast and more accurate if you're not confident. So pop it in a bus stop, pop your 2 outside. It's a simple short division. How many 2's fit into 2? 1. How many 2's fit in 4? 2. How many 2's fit in 0? 0. How many 2's fit in 0? 0. Your answer is 1200 both times. Remember to pop it in your answer box. Here we have another inverse question. We know that something plus 70 makes 485. So this time I'm going to start with my bar model. Doesn't really matter if it's not to scale, but I am going to just make it to scale. I know the first number is going to be bigger. It's not quite to scale because 485 is quite a bit bigger than 70. So if this bit's 70 and the whole thing adds up to 485, that might help you to visualize what to do. You don't need to draw a bar model if you can already visualize what to do. If you can already see it's the inverse, we want to undo the adding of 40, we want to reverse it, we want to do the opposite of it, the inverse of adding subtraction. So to find out what this missing value is, we're going to have to do 485 subtract 70. Now, you may be able to do that mentally, as you may spot that actually all we're doing is taking away 7 tens from 485. That is something you should be able to do fairly simply mentally. However, if you're not very confident, and sometimes we can get a little bit under pressure when we're sitting a test, and all the things that we can usually do that we find quite easy suddenly don't become easy. In that case, don't put the pressure on yourself, just write it out. Okay, you could probably do this fairly quickly. Just write out 485 take away 70, and that way you will know, you'll feel less pressure that you've got it accurate. 5 subtract 0 is 5, 8 subtract 7 is 1, and 4 subtract nothing is 4. Remember to put your answer in the answer box. This is a simple addition problem. As with question 1, the main thing we need to worry about here is lining the digits up correctly. Now with decimals, remember, just look for the number that is worth 1, our ones, and make sure that is lined up. So we've got 6. I'm actually going to put the decimal in its own square. It doesn't need to be 0.48, and 8.6. Okay, now what I always do is if there are gaps after the decimal point, so very important, if it's after the decimal point, you can use placeholders, so I can put a 0 in there. 8.6 is not written as 8.60, but 8.6 is exactly the same as 8.60. It is not a different number. In fact, I could put endless zeros on and they are both still the same number. For efficiency, we don't worry about writing all the zeros on at the end, we just shorten it down. Very important, you can only do that after the decimal point. So I've now got two numbers with the same amount of digits, they are lined up correctly, and I can just add this as I normally would. 8 plus 0 is 8, 4 plus 6 is 10. Remember to carry the 1 past the decimal point. So from the tenths column, it's going to be carried over to the ones column. Now we've got 6 plus 8, which is 14, plus your carried 1 is 15. Remember, when you write it in, to put your decimal point in. It's very important that your decimal looks like a decimal as well. I'm using an on-screen pen, so it's not always that accurate. Just be careful that, because sometimes the examiners will read your decimal point as a comma. So just be really careful that your dot is a dot and not anything that could be mistaken for a comma, like something like that. If I did it like that, that would get read as a comma. I know it's quite brutal, but that is what the examiners have to do. So just be very, very careful how you write your decimals. Okay, now the one that I've written in there, I would even be a bit worried if that might get seen as a comma. So I might just make it rounder if I was doing that in a paper, just to make it really clear it's a decimal and not a separator. Here we have a calculation where the answer, I'm using inverted commas, answer is on the left side instead of the right side. We are used to seeing a number sentence, then an equal sign, and then a value, then an answer as such. Okay, all the equal sign means is that both sides are the same. That's all it means. The answer does not have to be at the end. All it means is that the left side is the same as the right side. So if I was to draw that in a bar model, I would have my 240 divided by 8. And what it's saying is that the bit where 240 divided by 8, that bit there, is the same as your answer. So we're looking for that bit. We're just in fact, you didn't need to draw the box at the bottom. It's literally just looking for that bit. So really, all we have to do is just solve it. If it had been written like this, it would have looked a lot simpler. You would have just known what to do. But just because the box is put at the beginning, it can throw a lot of people. So we're just doing 240 divided by 8. You might have spotted using known facts. So you might think, well, I know what 24 divided by 8 is. That's 3. So I know that 240 is 10 times bigger. So my answer is going to be 10 times bigger. However, if that's not something you're very confident with, I'm more interested in you being accurate than worrying about the time. But if you know you can be accurate, then save the time. So quick bus stop like that. 8 into 2 does not go. We haven't used our 2. So this is short division, this method I'm using. Long division would require you to do the bit where you put it underneath and draw your arrows down. 8 into 24 goes 3 times. 8 into 0 doesn't go. Now, this is where some people get caught up. Remember, we do need to go 8 into 0. It doesn't go. We put 0. There's nothing to carry over because it's a 0. The remainder is just 0. So that's our answer. It's 30. Remember to write it in the answer box. And just remember that it doesn't matter where the values are each side of the equal sign. All the equal sign means is it's the same as. So this is just saying 30 is the same as 240 divided by 8. This question is a simple short division. I would get working straight away in a bus stop. Again, you might be very good with your mental calculation. You might have a strategy where you decide to divide by 10 and then times it by 2. That's fine, but I always find it's just easiest to just pop it in a bus stop unless you're super confident. So 5 into 8 goes once. There is a remainder of 3. 5 into 34 goes 6 times. 5 times 6 is 30, so that means there's a remainder of 4. And 5 into 40 goes 8 times. Now, if you are using the long division method, you would have done, I'm going to just pop it down over here. You might not be confident with the short division method. You might only use the long division method, which is absolutely fine. 5 into 8, it goes once. We proved that 5 times 1 is 5. And then we subtract that. 8 take away 5 is 3. And we bring the next number down. Oops. 5 into 34 goes 6 times. We prove it. 5 times 6 is 30. We subtract it. 34 take away 30 is 6. And then 34 take away 30 is 4. And then we bring the 0 down. Don't write it like I have where it's gone into the box. 5 into 40 goes 8 times. We proved that 5 times 8 is 40. We subtract it. We have 0. We know we've got to our answer. Remember, the answer is the number that you have on the top. On the top of your bus stop, it's this. And remember to write your answer clearly in the answer box. 168. Please do avoid what I did where I drew over the answer box. Here we have a simple subtraction. As with the addition, the main thing is that you line your digits up correctly. Use the squares to help you pop each digit in separately, and it helps you to make sure that everything is lined up. Obviously, if you have a ruler, you can put your lines in. It's not really necessary for the calculation. Now, we are doing 6 subtract 7. Hopefully, you have learned that we can't do 6 subtract 7. So we're going to be doing some exchanging and some regrouping here. So we need to go to the 0. There's nothing there. We need to go to the 3. That's going to become a 2. That becomes a 10. That becomes a 9, and that becomes a 16. 16 subtract 7 is 9. 9 subtract 4 is 5. Now 2 subtract 8 we can't do. So we need to pop over to the 7,000s, borrow 1,000. So that's going to become 6,000. So that can now become 1200s. 12 take away 8 is 4. And 6 take away 1 is 5. If you're ever not sure, you can simply do a check calculation. So you can take your answer, 5, 4, 5, 9, and add in the number that was subtracted. 1, 8, 4, 7. And you can do a check calculation to check. 9 plus 7, I'm going to do it in a different colour. 9 plus 7 is 16. 5 plus 4 is 9, plus the 1 is 10. 4 plus 8 is 12, plus the 1 is 13. And 5 plus 1 and the carried 1 is 7. And we can see that that works. We've used our check calculation. We know we've got our answer. If you do feel like you need to do your check calculation, please make sure that you then put the correct answer in the box. You don't put the 7306 in the box. I have seen that done before. So the answer to this question is 5459, 5,549. Here is another question which doesn't require you to do a written calculation. It just requires you to show you understand what you do when you multiply it by 10. Okay, so by now you should have learned that when you multiply something by 10, the numbers are going to get bigger. The number is going to get bigger because you're multiplying, but each digit just moves over one space. So if I was just to quickly write out, and I wouldn't expect you to write this out in your SATs because you don't want to waste any time. This is just for demonstration purposes. I'm also going to write in 10,000 because I know my number is going to get bigger. So if I was to write my original number in, so remember this is just for demonstration purposes, I've got the number 1010. When you multiply by 10, every digit just moves to the left by 1 space. Okay, so those are my original digits. I'm going to put my separator in. We cannot leave the ones column blank. We put a placeholder in. Okay, so my 1010 becomes 10,100. If I can just highlight the original numbers. So my original digits are 1010. There is my 1010. Those digits do not separate from each other. They stay together. I've still got 1010. They've just moved up a place and value. The 1000 becomes 10,000. The 000 becomes 0,000s. The 110 becomes 100. The 01 becomes 010. And then we need to add in our placeholder. We can't leave our ones column blank. Okay, so our final answer is 10,100. There is no need to put the separator in. I like to put a separator in after to show the difference between the thousands and the hundreds. But please do make sure that it looks like a comma and not a decimal. Okay, so don't write it, like that, where it could be mistaken for 10.1. Make sure it is slanted. Yeah, it's clear that it's a separator. Or if you're not sure you can do that, just leave the separator out. In this question, it's another question where you could be speedy if you're very confident. You might spot that we could use 56 divided by 7. If you're very confident with your tables, if you know 56 divided by 7 is 8. And if you can do this in your head, certainly don't write it out. I'm writing it out to demonstrate what you would be thinking. Okay, if 56 divided by 7 is 8, because you're confident with your tables, 560 is 10 times bigger than 56. So my answer is going to be 10 times bigger. So you may have spotted that, and you may be able to spot that link mentally, which means write it down. You don't need to do a calculation. It saves you time. However, if you're not super confident, pop it in a bus stop. Just move this back over. And if you're not super confident, which is absolutely fine, we want to be accurate, pop it in a bus stop. 7 does not go into 5. We haven't used the 5, so it gets carried over. 7 into 56 is 8. If you're not very confident with your 7 times table, a tip I would give is to write out your 7 times table. So have a look on the left hand side. I'm going to write out my 7 times tables, and if you find it hard to count up in your 7s, for example, the second one, you might know your 2 times table, so 7 times 2 is 14. The next one, you might know your 3 times table, 7 times 3 is 21. But also what you can do is add 10 and then subtract 3. So 21 add 10 is 33, take away 3. So 21 plus 10 is 31, take away 3, 30, 29, 28. Plus 10 is 38, count back 3, 37, 36, 35. Okay, so you could do it like that. So find a method for jotting down your, you'll see I've got to 56. So 1, 2, 3, 4, 5, 6, 7, 8. Which we've done. And 7 into 0 doesn't go. There's nothing remaining. Can't carry the 0 over. That's our answer, 80. And you'll see it's the same answer as recognising that 56 divided by 7 is 8. So 56 tens, which is 560, divided by 7 is 8 tens, which is 80. In this question, we need to multiply 3 numbers. Like adding, when we multiply, it does not matter what order we complete the multiplications in. So a lot of you would probably do 6 times 10 is 60. And then think, right, I've got to do 60 times 11 now. Okay, and then you might do a long multiplication, 60 times 11. However, we want to be efficient, okay? So what I would suggest instead is to actually do the 6 times the 11, okay? So 6 times 11, I'm going to write it out again, times 10. We're going to do it this way round. And the reason is because 6 times 11 is fairly simple, 66. And then 66 times 10 is fairly simple because, like I said in the previous question, when we multiply by 10, we don't need to do a long written out calculation. We just need to recognize that each digit moves along one space. So 66 becomes 660. This makes that calculation a lot quicker than if you were to do 60 times 11. Okay, just so you also know, you could also do 10 times 11 and then times that by 6. But in my opinion, you want to leave the multiplying by 10 to the end, because whatever number you've got, multiplied by 10 will be the simplest calculation to do. And remember to write the final answer in, 660. Here is a division question that you can save time on if you are very confident with your divisions, your times tables. So you might spot these 3 digits. If you know what 108 divided by 9 is, which is 12, that will help you with this. You can see that the 108 is in 1080. It's 10 times bigger. So your answer is going to be 10 times bigger. You do not have to write that out. That should be something that you can do mentally. If you're not super confident and you want the reassurance that you're being accurate, it's the good old bus stop. 1080 divided by 9. 9 into 1 does not go. We haven't used that 1, so it does need to carry over. It's a remainder. 9 into 10 goes once. There is 9 times 1 is 9, so there is a remainder of 1. 9 into 18 goes 2 times, and 9 into 0 goes 0 times. Our answer is 120. Here we have a simple subtraction. Again, with any addition and subtraction, it is imperative. That means it's really important that our digits are lined up. I am putting the separator in to show the separation between thousands. That does actually help you if you look at the question, because it does help you to line it up correctly. You can clearly see that I've put the separators in that are in the question, and I've made sure the separators are above each other. I'm happy that all my digits are lined up. And now it's a simple subtraction. 0 take away 0 is 0. Let me put this in a different colour. 0 take away 0 is 0. 0 take away 0 is 0. 0 take away 0 is 0. Now, this next bit, 0 take away 5. We can't do 0 take away 5. If we go to the next number to exchange, we'll see there's nothing there to exchange. We need to go over to the 100,000 column, to the 500,000s, and take 100,000 and leave that as 400,000. That 100,000 is going to go over to the 10,000 column. Okay, so we would now have 10,000 there, and we can borrow a 10,000. So we're going to take one of the 10,000s away. So that's now 9. And we can bring that 10,000 over to the 1,000 column. That 1,000 over to the 1,000 column. So we've now got 10 in our 1,000 column. We've now got 10,000, take away 5,000 is 5. And now we've got 9, take away nothing. So 90,000, take away nothing is 90,000. And then we've got our 4 in our 100,000 column. 4 take away nothing is 4. Okay, put our separator in. To do a check calculation, you take your answer, 495,000, separator in, and we add the number that we subtracted, and let's just check that it gets to the same answer. 0 plus 0 is 0, 0 plus 0 is 0, 0 plus 0 is 0. 5 plus 5 is 10, 9 plus the 1 is 10, and 4 plus the 1 is 5. Okay, I'm happy. That is the same as that. If you do that, please remember to put the right answer in your box. Don't put the number from the last calculation. That was just to check that it was correct, and you only need to check that it's correct if you are a bit unsure. It might be something you do once you finish your paper and you go back, and if you've got time to go back and check over anything, do some check calculations, because that might be where you find you've done an error here or there. We all make errors, however good at maths we are. So our answer is 495,000. You may also have been able to do this mentally, okay? 500,000, take away 5,000. If you think about it as the thousands, I've got 500, take away 5. I know 500 take away 5 is 495. 500,000 take away 5,000 is 495,000. So it may be something you could also do mentally, but only attempt that if you are super confident, you absolutely know you're going to be accurate, and perhaps at the end you'll have time to go back and check it. Okay, remember earlier on we looked at the equal sign. All the equal sign means is the same as. It doesn't matter what order it is in. So we can actually think about this question as 596 times 7 equals. And that makes it easier for us to visualize that all we are doing is a short multiplication. 596 times 7. So 6 times 7, you're using your times tables here. As I said earlier, if it helps you, if you're using your 7s and you want to write out your 7s to help you, that's fine. It might just help you so that it might be quicker. You only need to go up to 10 lots of 7. That might help you. If you don't need to, then don't do it. Always think about saving time, but accuracy comes first. So 6 7s are 42. And you could use your list on the left if you weren't so sure. 9 7s is 63, plus your 4 is 67, and 5 7s is 35, plus your 6 is 41. And you write the answer in the box. It is the same as this. 596 times 7 is 4,172, and 4,172 is equal to 596 times 7. So for this question, it might look intimidating. You might be thinking about how you're going to put this in a bus stop and you've got a decimal number. We're literally just using the same knowledge we used earlier with the timesing by 10 and applying that to dividing by 10. When we divide by 10, the digits just move to the right because they are becoming smaller. So I'm going to write out, we've got a 1, we've got a 10th, and we've got a 100th. And I know that my number's going to get smaller, so I'm going to put in a thousandths as well. If I wrote in the number, and I don't expect you to do this in the SATs paper, but you can if it helps you to visualize. There's my original number. When I divide, my number gets smaller. Dividing by 10, there's 1 0. That means it moves 1 space. My 2 is going to move 1 space. It's going to move, the 2 1s becomes 2 tenths. The 1 10th becomes 100th. the 100th becomes 1,000th. Oh, sorry, that should be a 2. The digits do not change. The digits stay the same. So you can see, if I just highlight, we've got the digits 212, 212. We've still got 212. They're still together. They do not move. However, we cannot leave our ones column blank. We put a placeholder in, a 0, and we need to use a decimal. So the answer is 0.212. We do not need to do 2.12 divided by 10. It will become very complicated if you do that. We need to know how to times by 10, 100 and 1,000 and divide by 10, 100 and 1,000. Digits stay together. They just move to the left or move to the right. They increase in value or they decrease in value. Just think to yourself, if I'm dividing something, it gets smaller. If I'm multiplying something, it gets bigger. If you need to write out the place value headings like I did, then you can do that. Here we have a bit of long division. It's already written in the bus stop for you. So we know we're going to be doing some long division. If it helps, and I always feel like it does, write out your 21 times table. So what I would normally do is I would just quickly write out up to 10 because you only need to know the first 10. Let me write in a different colour the actual 21 times table. 21, 210. 5 lots is going to be half of your 10 lots. So that's 105. I have a short course on long division, which covers all of the division strategies. Runs through, gives you lots of practice at doing questions like this. Just going to add up in 21. I'm not going to go through the strategies of how to add up 21. If you do want to look at that, it's in my long division course, but you can just write out your 21 times table. Okay, now you've got your 21 times table written out. It's going to help you to solve it. So 21 does not go into 6. 21 times 0 is 0. 6 take away 0 is 6. Bring down your 7. 21 into 67, we can see if we look over, it's only going to fit in 3 times. And we prove it. 21 times 3 is 63. Write it underneath and subtract it. 67 take away 63 is 4. Bring the next digit down. And 21 divided by 42, we can see it fits in 2 times. We're just going to prove it. 21 times 2 is 42. Subtract it and we have 0. So we know we've got to our final answer. Remember, the answer is the answer at the top of the bus stop. I have seen lots of times when marking SATs papers, you go to a big effort to do all the calculation and done it all right, and then you just take your answer from the wrong part. Remember, the answer is the bit on top of the bus stop. The answer is 32. Doesn't matter if you put the 0 in front, but we wouldn't write in maths 032, you just write 32. Okay, so we have fractions, adding fractions here. Remember, we can't add fractions if they do not have the same denominator. We need them to have the same denominator. I can see here that I can change my thirds to ninths, so there's no need to change my first fraction. I'm just going to write that there. And my 2/3, I'm going to change to 6/9. Okay, we just need to make sure that they have the same denominator. If you are not sure how to find equivalent fractions, so to find out how to change a fraction so that they have the same denominator, I have got lots of fraction courses that teach this skill. Once you have got them in the same denominator, you can simply add across the top. We know that the answer is going to have a denominator of 9 at the bottom. And then we can simply add across the top. 4 plus 6 is 10. So 10/9 is the correct answer, but you can also see that that can be changed to a whole number. So 10/9 is the same as 9/9 and 1/9, which means it's the same as 1 and 1/9. So my answer is 1 and 1/9. 10/9 is also the correct answer. Just be very careful if you write two values of fractions in the answer box, because if one of them is wrong, you will get the whole answer wrong. So for example, if you knew how to get the 10/9 and you didn't know how to change it to 1 and 1/9, I would just leave 10/9 in the box. But if you wrote one of these correctly and one of these incorrectly, your whole answer will be marked wrong. Here we have a simple long multiplication. If you are not sure on long multiplication, I have a lesson on this in my Pocket Private Tutor app. It's one of the free lessons if you download the app, or you can log on to my Facebook group and I've got all the free videos on there as well, or look at my YouTube channel. But let's have a quick go at solving this. I'm not going to pause and talk too much about each part, but let's have a go at solving it. So we're going to start with multiplying everything by the ones. So 7 times 3 is 21. 0 times 3 is 0, plus the 2 is 2. 6 times 3 is 18. We're now going to multiply everything by the 80, the 8, which is 80. Because this 8 is actually 80 and not just an 8, we need to put a placeholder in before we do any calculating. And now we can begin. 7 times 8 is 56. 0 times 8 is 0, add the 5 is 5, and 6 times 8 is 48. Now that we have all our digits in, I'm just going to cross out the numbers that I've carried so they don't accidentally get added up. We're going to add everything up. 1 plus 0 is 1. 2 plus 6 is 8. 8 plus 5 is 13. 1 plus 8 plus the other one is 10. And 4 plus 1 is 5. I'm going to put a separator in there. Don't need to. The answer is 50,381. Okay, in this question, we're timesing by 1,000. Remember, timesing by 100, 10, 100 or 1,000, we don't need to write out a big calculation. We just need to recognize that we're just moving all the digits over. There are 3 zeros in 1,000. That tells me I need to move each digit over 3 spaces. Now, at the moment, I've got a 10, so at the moment, we've got a 10, we've got a 1, we've got a 10th, we've got a 100th. Okay, it's my decimal numbers. My number's going to get bigger. It's going to move 3 spaces, so I need to write the next 3 in. So after 10s, I've got hundreds. I've got thousands, and then I've got 10,000. Okay, so let's write our original number in, 13.5. And I'm just writing this for demonstration purposes. You do not have to write this out like this when you're doing your SATs. Each digit is going to move 3 spaces. So this digit, this 1, is going to move 1, 2, 3 spaces. It's going to move over to the 10,000 column. Remember, all my digits stay together. The 1, 3, 0, 5 is going to stay together. If I just show you with the pointer again, the 3, which is in the ones column, is going to move 1, 2, whoops. It's going to move 1, 2, 3 spaces. The 0, which is in the 10th column, is going to move 1, 2, 3 spaces. The 5, that's in the 100th column, is going to move 1, 2, 3 spaces. So everything has moved over 3 spaces. Remember, we can't leave the ones column blank. We put a placeholder in, so we put a 0 in there. So my number becomes 13,050. And if we think about it, 13 times 1,000 is going to be 13,000, isn't it? 13 thousands is 13,000. So we've got our 13,000. There's our 13,000. Separator tells me it's 1,000. And then I've got 50. Okay, the digits have stayed together. Let's just double check. I'll use the highlighter to show you. We've got 1305 together. 1305 and 1305. The digits do not move apart. They just simply move to the left or right, depending if you are multiplying or dividing. If you're multiplying, you're getting bigger. 1000 tells me I move everything over 3 spaces. You do not need to do a long multiplication method for this question. You just need to know that the digits are increasing 3 spaces. For this next question, we can see that the fractions have the same denominator, therefore we are able to add them as they are. Now we have fractions and whole numbers, so this is a mixed number, and we can partition. We can do our 1/3 and 2/3 first, and then we can add our 2 on separately. So if we were to add our 1/3 and our 2/3, we can see that we have 3/3. We then have our number 2. So we've got 2 plus 3/3. However, we cannot write the answer as 2 and 3/3. Okay, so if you wrote this, that would get 0 marks because you can't have an improper fraction and a mixed number together. It's got to be one or the other. So we would change our 3/3. Now 3/3 is the same as 1. So instead of 2 plus 3/3, we would think about it like 2 plus 1. So that our answer would be 3. Okay, so just remembering that once you have got your fraction in an improper fraction, you can change it to a mixed number. That was 1, and then we add that to the 2, the whole number 2. Okay, this question is quite common. Sometimes you'll also see it as 7/10 times 30. Just so you know, they're both the same thing. When we have a times or an of, they're both the same thing. When we are finding 7/10 of 30, you first of all want to find 1/10. So we divide by 10. 1/10 of 30 is 3. If 1/10 is 3, then 7/10 is going to be 7 lots of that. So 7 times 3, which is 21. So our answer is 21. We divide by the bottom number, the denominator, and then we multiply by the numerator. So just to recap, we found 1/10 of 30 by dividing by 10. We found 7/10 of 30 by multiplying our 1/10 by 7. Remember to write the final answer in the box, 21. Here we have another subtraction question. Now with decimal numbers, we need to make sure we are lining everything up. So as we did in an earlier question, just check which digit is the ones digit. So we've got 8 ones, take away 5 ones, and make sure you line those up correctly. So we need to have our 8 and our 5 over each other like that, and then we can put our decimals in. I'm going to put the decimal in its own box. You don't have to, but I'm going to make it nice and clear. And then we can see that we have a space above our decimal numbers. So with our 8, we're going to fill it in with zeros. Okay, 8.000 is the same as 8. It's got the same value. But what it does is it helps us to visualize what we need to do when subtracting. If we don't do that, let me just quickly show you what might happen, and what I have seen happen lots of times is we do this, and then when we come to subtract, I've seen lots of children sort of go, oh, there's nothing to subtract, so they leave that as 1, 2, 3, and then they do this. 8 to 8.5 is 3. That is not correct, but that is a very common error that I have seen. So if you make sure that you put in your 3 zeros at the top, the placeholders, it helps us to do the right thing. So now we're looking, we need to do 0, take away 3. Now we can't do 0, take away 3. We're going to have to do some exchanging and some regrouping. So when I look at this 0, I need to exchange. There's nothing here to take. There's nothing here to take. I'm going to have to go all the way over to my 8. So I'm going to take 1 from my 8 and leave that as a 7. And then I can bring my 1 over to the 10th column. Now that I've got 10 there, I can take 1 from there, leave that as a 9. I can put my 1 in my 100th column. I've now got 10 hundredths. I can now take 1 from there, leave that as a 9, and I can put 1 over in my 1000th column. I can now subtract. So 10 take away 3 is 7, 9 take away 2 is 7, 9 take away 1 is 8. Put your decimal point in, and 7 take away 5 is 2. And that is the correct answer, 2. Remembering to make sure your decimal point is a proper point. Lost my pen. 2.877. It's really important that digits are lined up, and that any spaces where there could be a decimal numbers, you just fill them in with placeholders so that you get the answer on the left, which is correct, and not the answer on the right, which is incorrect, but I have seen entered very frequently. This question is dividing fractions by a whole number. It is part of the Year 6 curriculum. I have 2 resources on this skill. One is the Year 6 fractions book, and the other one is the Focus on Fractions SATs revision booklet. So I will just quickly go through how to solve this. 1/8 divided by 2 is the same as 1/8 times 1/2. And to multiply fractions, we simply multiply the denominators and multiply the numerators. So 1 times 1 is 1, and 8 times 2 is 16. And there is our answer, 1/16. If you would like to learn more about multiplying and dividing by fractions, do check out one of those resources that I just mentioned. This question on adding fractions requires us to find equivalent fractions because we have 2 different denominators. We cannot add or subtract fractions when the denominators are different. We need to find equivalent fractions, of each fraction so that they both have the same denominator. Now 2 and 3 are not multiples or factors of one another, so we need to find a common multiple. So I can see that 6 is a common multiple, so I'm going to change my 1/2 to a fraction over 6, and I'm going to change my 1/3 to a fraction over 6, and then I'm going to add them. My 1/2 is the same as 3/6, and my 1/3 is the same as 2/6. Once I have the same denominator, I am able to just add them. I know that my denominator is going to be the same. It's going to be 6, and I simply add the numerators. 3 plus 2 is 5, and there is my answer, 5/6. If you would like any help with adding or subtracting fractions that have different denominators, you can check out my Focus on Fractions course or my Year 6 Fractions SATS ebook. Here we have a subtraction question where we have a whole number and a decimal number. As with all subtractions, and especially ones where decimals are involved, we need to line the digits up. However, when you have a decimal number involved, just always make sure that you think about which digit is worth 1. So I'm just going to highlight in both numbers which digit is worth 1, so that when I write it out, and I make sure that I've got lots of space, I'm going to start right over on the left. When I write my 26 in, I know that the 2 needs to line up with the 6, because in 26 I've got 6 ones, and in 2.012 I've got 2 ones. So the 2 must go under the 6. I'm going to put my decimal point in its own square. It's not essential, but I'm going to do that, and then write the rest of the digits in. I always suggest when you are, I'm going to also put my subtraction sign in just to remind me. I also suggest that when you're calculating with decimal numbers, that you make both numbers have the same amount of decimal places. So with my 26, I'm simply going to add in a decimal point and then pop in some placeholders. This is so that they both have the same amount of decimal places. What it also means is that you won't make a very common mistake of leaving, I'll write it over on the side, it's a bit like the one I did earlier on. What you see a lot of in this question, if you've remembered to line them up correctly, because that's also something that can go wrong, what we see a lot is this, and then what we see is these numbers left the same, and then 6 take away 2 is 4. We see that a lot. That's a very common error that's made. Make sure the numbers have the same amount of decimal places, whether you're adding or subtracting, and then you can start to subtract. You will see that when we do our first subtraction, 0 take away 2, we obviously can't do that. We can't take 2 thousandths away from 0 thousandths. So we're going to have to do some exchanging and some regrouping. We go to our digit in our hundredth. We can't borrow a hundredth. We can't borrow a tenth. We need to go over to our ones section, and we need to borrow 1. So that is now going to be 5 ones, and we're going to take that 1, and that's going to become 10 tenths now. Okay, so we've added the 1 there, and now we can borrow a tenth, and that's going to become 10 hundredths. Now we can borrow 1 from there, and that can become 10 thousandths. Okay, so you can see that we've gone to each neighbour to see if we can borrow 1. And we keep going until we're able to borrow a 1 from the 1 section. Then we have to give it to the 10th section before we can borrow 1. Okay, so now we can subtract. So 10 take away 2 is 8, 9 take away 1 is 8, 9 take away 0 is 9, 5 take away 2 is 3, and 2 take away nothing is 2. So with these questions, they can be a bit long-winded at the beginning because you're having to keep going over till you can exchange and regroup. But as soon as you've got that in, it's very quick to do. So the next part of it is just to remember when you're writing your number in that your decimal point is clearly a decimal point. It's very clear that it's a dot, not a squiggle or a line or anything slanted, so it gets confused with being a separator or a comma. It's completely obvious that is a decimal point. The next question, 15% of 3,200 could also be written as 15,000 times 3,200. If you ever see the times or the of, they are the same thing. So to find 15% of 3,200, I would find 10% and then 5%. To find 10%, you simply need to divide by 10. That is 320. To find 5%, I just need to find half of the 10%, because 5 is half of 10. Half of 320 is 160. And to find 15%, I simply need to add my 10% and my 5% together. And I can actually do that right here. 0 and 0 is 0, 2 and 6 is 8, 3 and 1 is 4. The answer is 480. If you would like some more lessons on calculating percentages, this is available in my Year 6 SATs ebooks. You will find it under. So finding 2% of 3,000 is the same as finding 2 100ths of 3,000. I'd break this up into finding 1% or 100th. We divide our 3,000 by 100. So if we divide a number by 100, it gets smaller. Each digit moves over 2 places. 1% or 100th is 30. If we know that 1% is 30, 2% will be double that. 2% will be 60. That's our final answer. Here we have a long division question. It's long division because the divisor 73 is not a times table that you would be expected to know off by heart. You're only expected to know up to 12 times 12. So this is a long division question. I would strongly suggest to list your 73 times table first. So I would, to the side, write a list of 1 to 10. And then I would list your 73 times tables. Now to do this, the first one is obviously 73 and number 10 is 730. You don't actually need number 10, but I like to use it just because it helps to make sure that the others are right. So to find number 5, we would halve your 730. Half of 730 is 365. Again, it gives us a benchmark. So when we're adding up in 73s, we can just check from 4 to 5 whether that does go up by 73. Okay, so fill in the rest. So I actually saw as I started to fill it out that I'd missed out the number 9, and that's because I got to 584 and I realised that there's a bigger gap than 73 between the two numbers, so that's where I spotted that I'd missed a number out. So that's why it's always good to list the numbers out and you can use those as benchmarks. So the final one after 584 is okay, and then now you can start to solve your long division. So how many times? 73 is not going to go into 3. It's not going to go into, so we can subtract it and then bring the next number down. It's not going to go into 30. Again, we can subtract and bring the next digit down. So we need to look at 306. We can look down our list of numbers. We can see 4 is the most that will fit in. And then we write 4 lots of 73 underneath, which is 292. And then we subtract it. And then we bring our last digit down. And 73 and 246, using our list, we can see it goes in twice. Prove it by writing what 273s are. Subtract it, we have 0, so we know we have our answer. Our final answer is the number on top of the bus stop, which is 42. In this question, we need to find 80% of 115. Now, there are multiple ways you can do this. Remember, 80% is the same as 80 over 100. So if we were thinking of finding 80 hundredths of 115, we would be dividing by 100 and then multiplying by 80. However, you can actually do that in a different order. So it would actually, in this instance, be easier to multiply 115 by 80. And then once you found your answer, to then divide it by 100. So once you've got your answer, divide it by 100. So that is one way you can do that. When you're finding percentages, you just multiply the percentage by the number and then divide your answer by 100 afterwards. Or what I like to do is to partition my 80%. And I'm going to partition it into 50% and 30%. Now 50% of any number is just half of it. Half of 115 is 57.5. Let me just section this off. And 30% we would find by finding 10%. 10% of 115 of 115 is 11.5. So 30% is going to be 3 lots of that. You can multiply it by 3, but sometimes that might be tricky because you've got a decimal. So it's just as easy to just add it over here. If I put my answer in a different colour, 3 5s are 15. Remember to put the decimal point in. 3 1s plus the 1 underneath is 4, and then 3 1s is 3. So 34.5. And then you need to add both of those together. So I'm just going to put that on a different part of the page. So we need to add 57.5 plus 34.5. So 5 and 5 is 10. Remember to put the decimal point in. 7 plus 4 plus 1 is 12. And 5 plus 3 plus 1 is 9. So you've got your answer of 92.0 or 92. Now let me just quickly show you if I was to erase this and if we were to do the multiplication. Let's partition this off just so you can see that we can get to the same answer. So 5 times 0, in fact all of that times 0 is just going to be 0, isn't it? And we do a placeholder. 5 times 8 is 40. 1 times 8 is 8 plus 4 is 12. And 1 times 8 is 8 plus 1 is 9. So we've got 9,200. If we divide 9,200 by 100, it means that each digit is going to move over to the right 2 places, and we would get 92. We get the same answer. Okay, subtracting fractions, like adding fractions, we cannot subtract, we can't calculate if the denominators are different. We've got 7 and 9. 7 and 9 are not multiples or factors of one another, so we need to find a common multiple. We need to find a times table that both of these belong to. So 63 is a multiple of 7 and 9, and I found that by multiplying the two by each other. Now, it's good to try and check to see if there is a lower number, so a lower common multiple, but in this instance there isn't. If I went through the 9 times table, 9, 18, 27, 36, 45, 54, 63, none of those are in the 7 times table until we get to 63. So we are going to make both fractions have a denominator of 63. Let me just rub that out. Make it a tiny bit neater. So we now need to multiply the numerators. So 2/7 I need to multiply by 9. The 7 I multiplied by 9, so the 2 I'm going to multiply by 9. That becomes 18 63s. The 1/9 I need to multiply both parts of the fraction by 7. Because I multiplied the 9 by 7, I need to multiply the 1 by 7. That becomes 7. So if I now have the same denominator, which I do, I can just subtract the top. I know that the denominator is going to remain 63. 18 subtract 7 is 11. Okay, I can see that that cannot be simplified because 11 is a prime number and 63 is not a multiple of 11. So that is the simplest that that fraction will go. So remember to write that in your answer box. And don't write your fractions like this. If you need any more help on any fraction topics, don't forget to check out either Focus on Fractions or the Year 6 Fractions SATS ebook. In this question, we have both a mixed number and fractions with different denominators. So there are different steps to consider. Now, I always suggest when you have a mixed number and a fraction that you need to add or subtract, especially when you subtract, to change your mixed number to an improper fraction first. So I'm going to demonstrate how to do that. It's not the only way that you can do it, but this is the way that I always recommend. So the first thing we need to do is to change 2.5 to an improper fraction. 2.5 as an improper fraction is 5/2. So we now have 5/2 subtract 2/3. Now we need to consider that they both have different denominators. So now we need to change them so they both have the same denominator. I can see that 6 is a common denominator, a common multiple. So I can change them both so that they are fractions out of 6. 5/2 becomes 15/6. It's still an improper fraction. 2/3 becomes 4/6. And now I can subtract them easily because they have the same denominator. 15 subtract 4 is 11, and my denominator is going to stay a 6. So 11 6 is the answer. If you want to change that to a mixed number, you can change it. It becomes 1 and 5 6. So the answer is also 1 and 5 6. You only need to put one of those answers in the answer box. If you put both in and you make an error in one of them, so for example, if you got the 11 6 correct, but then you put it as 1 and 4 6, you would not receive a mark. So only put the answer in if you are really confident that you can get that accurate. If you are unsure of any of the skills here, changing improper fractions to mixed numbers and vice versa, there is lessons on this in the Fraction Foundation course. This is actually a skill that is taught in Year 5. So you can find that skill taught in the earlier Year 5 fraction skills. So Fraction Foundation is a course on fractions that teaches all the fraction skills from Year 3, 4, 5 up to Year 6. The Year 6 fraction skills are taught in the Focus on Fractions course and the Year 6 Fractions SATs ebooks. But if you want to look specifically at changing improper fractions to mixed numbers and vice versa, then the Fraction Foundation course is where you will find all that information. Okay, so this is simply a long multiplication question, and what the examiners are looking for is that you understand the long multiplication method. So I'm just going to do things in different colours, but obviously this is not what you would do in your exam, but it's just so that I can talk through what we're doing. So we're first of all going to do 8 times 7. We're going to actually multiply everything by 7. So 8 times 7 is 56. And we remember to carry the 5. 7 times 7 is 49. Plus the 5 is 54. 0 times 7 is 0. Plus the 5 is 5. And 4 times 7 is 28. I am going to cross out the numbers that we have carried. We are next going to make sure that we've put a placeholder in. And I actually sometimes suggest putting the placeholder in to begin with, so that you don't forget. Okay, I'm now going to use a different colour to show that we are now multiplying everything by the 6. So 8 times 6 is 48. And this is the bit where it can get a bit complicated, because we are now writing the answer to 8 times 6 to the left. It's not underneath the 8, it's to the left, because we're actually doing 8 times 60, not 8 times 6. So you can see, if you read the digits, we've actually got 480, not 48. Okay, what I also sometimes suggest is just to do a little tick above, just to remind yourself you've done it, because it's really easy to forget which digit you're on in this method. So 8 times 6 is 48. We're now going to do 7 times 6 is 42, plus the 4 is 46. Carry the 4 underneath. 0 times 7 is 0. I'm going to tick it. Plus the 4 is 4. And 4 times 6 is 24. We've now got all our digits in. What I'm going to do is just cross out the ones that were carried digits so they don't accidentally get mixed up in our adding. And we finally need to add our numbers. Now make sure you carry on your adding underneath. Do not do this. I've seen this lots of times where it might look a bit messy, so we rewrite it out over to the side. Now the reason is if you do something wrong with your adding here, you won't get a method mark because the method is incorrect. For the method to be correct, it needs to go down. Okay, so it needs to carry on. You can leave a gap if you need to, That's obviously quite messy. So, and you could even write it over to the right just to make it clear, but do your working out on the left hand side. So 6 plus 0 is 6, 4 plus 8 is 12, 5 plus 6 plus 1 is also 12, 8 plus 4 plus 1 is 13, 2 plus 4 plus 1 is 7, and 2 plus nothing is 2. So just to be clear, just to make sure that you definitely get your marks and to give yourself a guarantee of getting at least 1 mark, even if you get one calculation wrong, carry your method on all over here underneath the original multiplication. Don't carry it on over here. If you do it over to the right, that's fine, as long as you make sure you complete the method over to the left as well. If your examiner can see that over on the left hand side, even if you got one of the numbers wrong, you could still pick up a mark. I'll put that separator in the wrong place. So 273,000 . It's very messy writing on a screen sometimes. So 273,226. Okay, here we have 10 subtract 2 1/4. Now there are multiple ways to do this. I am going to show you 3 different ways. The first way I'm going to show you is by partitioning. Now when you're partitioning with a subtraction sentence, you can only partition the number you are subtracting. You cannot partition the number you're subtracting from. Okay, so in this case, we would start with our 10 and I would do it in stages. So I would do 10, subtract the 2 first to give me 8. Then I would take my 8 and subtract the 1/4 to give me 7 3/4. Okay, that would require you to understand that when you take a quarter away from a whole number, you're left with 3/4. Okay, so we've got 7 3/4. You could also rewrite it as a decimal. So 10 subtract 2.25. And if you did that as a subtraction, you would have 7.75. Then hopefully you understand that 7.75 is the same as 7 3/4. Or the other way you could do it is by changing the 10 to a fraction, to an improper fraction. Now we're working with quarters, so that means we have to find out how many quarters are in 10. If there are 4 quarters in 1, then there are 40 quarters in 10. Our 2 1/4, if we change that to an improper fraction, 2 1/4 is the same as 9 quarters. Okay, we can now subtract. We know that we're going to be left with quarters, and 40 take away 9 is 31. So we have our answer of 31 quarters. Now this would need to be changed to a mixed number. We've got a mixed number in our question. We want our answer to be as a mixed number. To find what 31 quarters is as a mixed number, we do 31 divided by 4 is 7. So 7 is the whole number. There is a remainder of 3, so the 3 is the numerator, and we're working with quarters, so we have 4 as our denominator. You'll see all 3 different methods have come up with the same answer of 7 3/4. For tips on converting mixed numbers to improper fractions and vice versa, check out the Fractions Foundation course where I go through how to use that skill. If you want a bit more understanding on fractions changing to decimals, that is in the Year 6 Fractions SATS ebook. Here we have an order of operations question. Depending on your school, you may have learnt this as BODMAS, as BIDMAS, even as PEDMAS. Okay, the order of operations tells us that division and multiplication is done before addition and subtraction. So with this, we would be solving this part first. The 4 divided by 2 would be okay, the 4 divided by 2 would be getting done first. And we know that 4 divided by 2 is 2. And there's nothing wrong with you annotating your SATs paper like this either. There's absolutely nothing wrong with you writing over it like that. So we've now got 6 plus 2, which is equal to 8. And make sure you put your 8 in your answer box. Make sure you do not do 6 plus 4 is 10 and then divide it by 2, which is 5. That is a very common error that was made by lots of pupils when this question came out. Just remember with BODMAS, there's no brackets there because division is done before addition. 4/5 times 100. What we need to remember here is that when we're dealing with fractions and percentages, the multiply is the same as an of. So if I was to rewrite this as 4/5 of 400, it's often more obvious what you have to do. Okay, so to find a fraction of a number, we divide it by the denominator and then we multiply it by the numerator. And the reason is this: we're first finding what 1/5 of 400 is. To find 1/5 of 400, we are dividing 400 by 5. Now you might want to put that on a bus stop, or you might know that if you divide 400 by 10 and then times it by 2, it's the same as dividing by 5. So 400 divided by 10 is 40, and doubled is 80. You might also see that you could do 40 divided by 5 is 8, so 400 divided by 5 would be 80. Okay, now that you've got 1/5, we can figure out what 4/5 is by multiplying your answer 80 by 4. If you're looking for some effective revision to help you with your maths SATs, then check out the Pocket Private Tutor Shop. I have SATs ebooks and I have revision courses. The SATs ebooks cover every single thing from the Year 6 national curriculum, so you can be sure that nothing will appear in the paper that you haven't learned. Each ebook comes with a video which you can watch on a laptop, on a tablet, on your phone. You can even cast it to your smart TV if you want to watch it big. I have worksheets to help you practice the skill, and included are past SATs question examples. That means when you're learning a new math skill, I also include how that has looked in an actual SATs paper before. I also have some revision courses, I have practice arithmetic tests, I have loads of stuff that's going to help you to absolutely smash your SATs. So check out the Pocket Private Tutor Shop and download the course that's going to help you now.